So we've looked at function notation, we've taken a look at inverse functions, now I want to take a look at composite functions. So here I have an x value, I'm going to apply g function to it. So this is going to do something to x, so I can write it like this. I can write it as g of x. And we all know, after looking at function notation, that this is going to come out with an answer for us. Well, what about if I apply a new function to this answer? Well, my input is going to be whatever my previous answer was from my g of x. So that is what I'm going to put in to my f function. So I will now be doing f of g of x. So hopefully here you can see how I've combined the g function and the f function. And in function notation, we write this final term as f g of x. So the order of this f and this g is clearly very important, as what we did first was apply the g function and then apply the f function. So let's take a look at an example. So say I had f of x equal to 2x plus 1, and I had g of x equal to x squared minus 3. And I wanted you to find f of g of x. So let's think about which function we'd apply first to our x value. Well, as g is the one closest to the bracket, we'd apply the g function first. So if I apply the g function to x, I get this right-hand side. I get x squared minus 3. And now I'm going to apply the f function to g of x. And as this is g of x, this is what's going to go into my brackets. This term here is what is going to go into my brackets of the f function. So here, instead of writing 2x plus 1, I'll be writing f of x squared minus 3 So instead of writing f of g of x, I can simply write f of x squared minus 3. So instead of the x going into this function here, it's now x squared minus 3 going into that function. So it should be 2 times x squared minus 3 plus 1. So there I have f of g of x. So let's put some numbers in now. Let's see if it works with some actual values. So let's say I put 5 into here. So instead of x, I now want to put 5. So g of x, g of 5, is going to be 5 squared minus 3, which is 25 minus 3, which is 22. Okay, and now we're going to take that value and we're going to put it in our f function. So we're going to take 22 and put it into our f function. So 2 times 22 plus 1 is equal to 45. So you can see, perhaps it's easier with numbers, that I'm putting the answer that I got out of my g function into my f function to then get out a final answer. And that's what composite functions do. they take the answer from the first function and then they put it into the second function in order to get out the final answer. So if we go back to our flowchart before, you can see that instead of x, I'm now using 5. I'm going to apply g of x to it, so it's g of 5, which will get me an answer, which I'm then going to put in to f function, which will give me f of g of 5, which should be my final answer. Let's have a look at another example of this. This time I want to take the composite function and turn it into one function I can apply to a number. So again, let's have f of x equal to 2x plus 1 and g of x equal to x squared. And I want to find f of g of x. So first of all, I'm going to apply the g function to x. That's going to get me x squared. Now I'm going to apply the f function to g of x. Or, in other words, I'm going to apply the f function to x squared. So I'm going to do 2 times x squared plus 1. And this here should be equal to f of g of x. And so we've combined these two functions algebraically into one function, and that becomes 2x squared plus 1. And we can check this with numbers if you want to. So if I use the number 5 again, I can do it step by step. I can first put 5 into my g function, and what I'll get out is 25. I then take 25, put it in here, and I should get out 50 plus 1, which is 51. And I can do the same thing down here. I can just put 5 straight in to my composite function, and that would be 2 times 5 squared plus 1, and that should give me the same answer of 51. So there you go, that is how you combine two functions into a composite function. And remember that the order does matter, so if I had g of f of x, that would look very different from f of g of x. Let me just show you this quickly. So f of x is 2x plus 1, and then I'm going to do g of f of x. So inside my brackets here, I'm going to put 2x plus 1. So on the right hand side, I will have 2x plus 1 all squared. And if I expand this out, you can see that it gives a very different answer to what I had before. So here, if I put 5 in, I'd get out something very different. So as you can see numerically here, I've just proven it, that f of g of x is very different to g of f of x. So when you're doing these questions, make sure that the order of functions is the right way around.